Good morning, everyone. Happy Wednesday. Thank you for coming today. Today, homework assignment, oh no, that's not true, is it? No, we pushed that off to Friday. Okay, whew. So you don't have to turn it in right now. Yeah, sorry. I was all excited because, see, I was here last Wednesday, you weren't. But okay, so assignment 1 is due next time. But the one thing that's a little strange about assignment 1 is you will hand in hard copy. So word process something, print it out. If you have a hard copy, staple it. If you just did something online, put the link there, and then we'll be good. Thank you. Before class, we were attempting to work with the JD Easy robot, and he kept falling off the desk. I tried to put him back together, but oh well. Last time we took a look at BB-8, the little roll around the room thing, and that was totally an app controlled. It was just remote control. This robot, we didn't quite get there, can do some things autonomously. We can give him a set of instructions that, why do you personify him? We could give the robot a set of instructions and it can actually carry them out on its own. We're going to see a couple other robots here in the first unit and maybe even get a chance to work with them a little bit ourselves. And hopefully they won't crash and burn like that one there. Thank you. Current event. When you take a look in assignment 1, you're going to notice that there are 2 major manufacturers of CPUs. By the way, the brand on the outside of the box of your computer, those folks don't make CPUs. Apple doesn't make CPUs. Dell doesn't make CPUs. The 2 major CPU manufacturers are AMD and Intel. Interestingly, AMD, which has sort of always been lagging behind the Intel Corporation in sales, and last fiscal end of 2018, surpassed Intel in market share of CPUs. Interesting, perhaps, but the thing that relates to you is when you're looking at ads, you're going to see the CPUs either made by the Intel Corporation or the AMD Corporation. Once a unit, I'm going to share a bumper sticker with you that salutes one of the branches of the armed forces. This was the United States Navy's slogan, not their most recent one, but life, liberty, and the pursuit of all who threaten it. I'm going to ask a favor of you. If you know someone who has served or is currently serving in the armed forces, would you do me a favor? Would you send them a note? Just say thanks for your service. I know they would appreciate it. My father served in the Navy. He was a decorated World War II veteran. He's no longer with us. He's obviously a really old guy, even older than me. But people will appreciate that. If you know somebody who has served or is currently serving, just send them a note. Don't have to say much. Just say, thanks for your service. I know they'd appreciate it. Thank you. Onward. We are now at Roman numeral 5 in Unit 1. One of the guiding questions for us is, what are the grand ideas of computer science? So let's look at them, but more importantly, rather than just knowing what they are by definition, I'd like you to be able to see them in a context. So that's what we're going to focus on. The reason we're taking a look at the grand ideas of computer science is because the meaning of anything is connected, tied, or linked to its origin. So the origin of computer science is found in these grand ideas, and that's what we're going to investigate. If you're following my notes, I won't always do this, but I mentioned that I'm going to be skipping some things, so maybe early on I'll just mention that explicitly. Important for you to know, but we're going to talk about other things. The major focus of computer science in this class is problem solving. Algorithms, and we saw the definition for algorithms before, algorithms are instructions for solving problems. Algorithms, the first grand idea of computer science we encountered, are defined as instructions for solving problems. a lot of people would say algorithms are the most important of all the ideas in computer science. I may or may not go that far. I don't think we want to rank them necessarily. But I want to delve a little bit deeper into algorithms and the relationship between algorithms and computer science. Some people would claim that computer science is really the study of algorithms. So let's look at what this says, and we'll look at it in 4 areas. Computer science is the study of algorithms, including A, their formal and mathematical properties. Ooh, I mean, that sounds horrible, right? Their formal and mathematical properties. This course, CSC 150, satisfies CUW core requirements in mathematics. Does it surprise you that we're going to be talking about formal and mathematical properties? Hopefully not. Now, let's make it a little easier. I always talk about this as the idea of the software. For example, last time on Monday we saw geoclock. We did see geoclock, right? That worked here? Okay, good. We saw geoclock where the sun was shining. And you discovered that there are algorithms that determine where's the shadow, where's the daylight on planet Earth given the date and time. In order to create that app, somebody had to have that idea. Oh yeah, you know, there's a mathematical relationship between day and time, angle of the Earth, and where the sun is shining. That's the idea of developing the algorithm. Computer science is the study of algorithms, including, secondly, their hardware realizations. Bless you. We know that in order to solve problems with a computer system, we have to have hardware, the capabilities. I can't run geoclock in my brain. I have to run it on a set of hardware. The third aspect of algorithms, computer science is the study of algorithms, including their linguistic realizations. Linguistics refers to language. The language of computer science is software. The language of computer science is software. These two things taken together, I refer to as implementation. That's an I. When the creator of geoclock started with this idea, then the creator said, well, it's not going to help if I just have the idea. Other people need to experience it also. So using some hardware, developing the software, and now I have geoclock. There's one more aspect. Computer science is the study of algorithms, including, finally, their application. That's the easy one, because we work with apps all the time. Computer science study algorithms, including their application. I'm going to refer to this as, interaction. Geoclock will do no one any good if you don't use it and interact with it, if you don't run it, work with it, etc. These are all about algorithms. The idea, the mathematical properties, the implementation in hardware and software, and then the interaction with the app. So tuck that away, and let's see that in the context of a couple algorithms. We did go in the lab. We called that the start button, right, in Windows? In Chuck Norris Windows, copyright, the start button is named Finish. Chuck doesn't start things. He finishes them. Okay, all right. All right, second week. It's time to start. Oh, okay, we didn't have a full first week, did we? Okay. A little bit psych. You're going to have to learn how to laugh. These are really funny. Remember. Let's look at a couple different algorithms. Now, let me just state this. Let me not prove it right now, but I think after we look at some algorithms, you'll see, yeah. Statement of fact. Creating algorithms is difficult. This is hard. What we're going to do in this class, before we come up with the idea and create them, we're just going to look at them and see how this all works. Creating algorithms is difficult. Here's the first algorithm we're going to investigate, and that is Easter. Now, if you don't know what Easter is the most important holiday for a Christian. It's a celebration of Jesus' resurrection, his victory over sin, death, and the devil. If you go into our chapel is set up with the bookends of Easter. If you walk into our chapel above the altar, this is Christ crucified, this is Good Friday. And then when you turn around to leave, that stained glass above you, that's Christ triumphant, rising on Easter morning. Now, you probably realize that Easter isn't always on the same day. Easter is a variable holiday. Unlike Christmas, that's always December 25th, Easter can be on different days. So question, when is Easter? Well, I think I'll just Google that and find, well, how does Google figure it out? You know, by the way, if you don't know the story, it will certainly be shared with you in Religion 100 and Religion 110. But the classic comment, this is the angel meeting the women at the tomb. You know, the men were too afraid to go out, so it was the women who went to the tomb. The angel says, why do you look for the living among the dead? He is not here, he has risen. By the way, I hate pictures like this. Almost always, angels are pictured as some kind of effeminate, fluidity. Angels don't look like that. Angels look like Chuck Norris. Angels take names and kick behind. That's what angels do. I always told my classes, I wish somebody would draw a Chuck Norris angel so I didn't have to Photoshop it. And a couple semesters ago, Rachel Ploutz drew that. Ooh, that's pretty cool, huh? Yeah, okay. Angels look like this. All right, that's what they look like, just so you know. So, when is the date of Easter? Well, interestingly, over the years, a couple different people have tried to come up with an algorithm. Here's what the Council of Nicaea said circa 300 AD. The Council of Nicaea, I hope I can remember this because I forgot to bring my notes. Council of Nicaea said the date of Easter is the first Sunday, occurring on or immediately after the spring equinox, occurring on or immediately after the full moon. What is that? Well, Easter has to be a Sunday. Christ historically rose from the dead on a Sunday. We always celebrate Easter on a Sunday. What's this moon and spring equinox? That's the date of Passover, and that's when Christ was crucified. So that's how it's determined. Well, how would you know, thinking ahead 20 years, when the date of Easter might be? Here's the algorithm. Now, I warned you last time it might be helpful to have this in front of you. This isn't even the full thing. There are 10 steps. We're going to step through this. Why? Not just for my own benefit, but you probably want to figure this out too. You want to guess why you may want to know how this works? It's called assignment 2. So let's, divide x by 19, attain a quotient and a remainder, modulo, and what is all this? Let's talk about algorithms in general, and then let's look at this Easter algorithm. A couple things to note about this algorithm. First of all, this algorithm, Easter, employs arithmetic operations. If you look back here, you can see add, subtract, multiply, and a lot of divides. Add, multiply, subtract, and a lot of divides. It uses arithmetic operations. The other thing that we're going to say about this algorithm is it follows what we're going to call in computer science sequential execution. You do step 1 first, and then you do 2, and then 3, and then 4. Probably makes sense. That's sequential execution. Do the steps in order. The other thing is this divide operation. It's not like what you're familiar with. This divide is how computers divide. It's called integer division or modulo. So let's take a look at that. The division isn't a calculator. This is what computers do. So let's pick a year like 20. You're saying, why don't we pick this year? Oh, I'm going to ask you to do this year. So let's pick 2025. The algorithm says pick any year of the Gregorian calendar and call it X. X? What's that? Well, this is known as a variable. You're familiar with this in mathematics, right? You do that in algebra all the time. The way I like to think of a variable is think of it as a box that has a label on it. And inside that box, you're going to put a value. So I have this variable that the algorithm calls X. Inside the box, I put a value, 2025 in this case. Now, I have to actually write all this stuff down. I cannot keep track of it in my head. Maybe you can. But I need to write all this stuff down, otherwise I can't remember it. So here's my variable X in the box. And I'll write 2025 in that, and then I'm set. All right, here's step 1. Step 1 of the algorithm says take X. What the heck's X? Well, I better look in my box. Aha, here's my variable X, 2025, 2025. Divide it by 19. Ooh, warning. This is how computers do division. It's called modulo arithmetic, math majors. And here's what happens. When you divide the way computers do, you get a quotient and a remainder. Remember when you first learned to divide? Like in, when is that, like 3rd grade? Senior in high school? When did you first learn how to divide? Something like that, okay? And then, you start off with the easy things. 6 divided by 3. 2, 8 divided by 2. 4. And then the teacher throws the old curveball. 7 divided by 3. Let's see, 2, no, 3, no. What? And then the teacher says, well, think of it this way. 3 goes into 7 2 times evenly with a remainder of 1. That's modulo arithmetic. Same thing here. How many times does 19 go into 2025? Answer, 106 times evenly. 106 times 19 is 2014. 2025 minus 2014 is 11. If you do it on a calculator, you get this, right? 106, but don't do that. That's not what we want. We want the quotient and then the remainder. And by the way, the algorithm says, I don't care about the quotient. All you have to do is remember the remainder. Make another box, call it A, write the data in there, and we're set. We'll do it again. To solve this algorithm, don't whip out your calculator. Divide things and come up with a quotient. How many times does it go in there evenly? And then a remainder. It's not going to be 106 point. There's no points here. So again, notice this use of variables. All algorithms, all mathematical ideas in computer science are built on variables. Boxes that are labeled that hold values. You're saying, why are they called variables? Because the contents can vary or change. So here's my X, wrote it down over there. Here's my A. You're just going to have to keep track of that stuff. This is how a computer does it. if you want to solve the problem. In step 1, when you look at the algorithm, it says divide x by 19 to obtain a quotient, which will be ignored. I don't have to remember the 106. And a remainder a. I'll remember the a, 11. Step 2, 2025. Take x. What's x again? 2025. Divided by, oh, this one we could probably even do in our head, maybe. 2025 divided by 100. 100 goes into 2025 20 times evenly, right? That's 2,000. Our quotient b is 20. And then 2025 minus 2,000 is 25. That's our remainder, which the algorithm says call C. Don't whip out your calculator. How many times does 100 go into 2025 evenly? Answer 20. 20 times 100 is 2,000. And then there's 25 remainder. That was step 2. Step 3 says, okay, take b divided by 4. Oh, weird. 4 goes into 25 times evenly. Sometimes then people get confused. So what's the remainder? There's still a numerical remainder, right? It's 0. 0. Sometimes the remainder might be 0. Sometimes the quotient might be 0. 0 is a number. It's a good number. 0 is okay. So that's step 3. B divided by 4 gives me 2 things. Quotient D, remainder E. Write those down. You'll have to remember them. And then it keeps going. We won't go through all the steps, but in the next step, I just want to point out something. This is called the mathematical precedence. Maybe, oh, gee, PEMDAS, is that it? I can never remember that acronym. Math majors, you know, this thing. PEMDAS, parentheses, exponentiation, multiplication, division, addition, subtraction. That's the order that we do things. So, for example, let's say I had, now this, if you do it left to right, you get the right answer. 8 times 20 plus 13. But what if it was 8 plus 20 times 13? What do I do first? I do that first. I multiply first, and then I add. You get a different answer if you add first and then multiply. So the precedence, both in mathematics and computer science, says parentheses supersede stuff, with no exponentiation. Multiplication, division are done before any addition, subtraction in the same level of parentheses. Woo. Fun. When you go all through this algorithm, when you step through all 10 steps, at the very end, you look at 2 different variables. N, which will either be 3 or 4, and P, which is a value between 1 and 31. N will tell me the month, April. P will tell me the day of the month. So, in 2025, 6 years from now, Easter will be on April 20th. Cool. There it is. I hate the term Good Friday. Why? My Lord was hanged on a tree that day. If you were going to be hanged on that day and he volunteered to take your place, how would you feel? Good. Have a nice day. Let's get started for 2019. This is X. The first step in the algorithm says to, what's the first step in the algorithm? Thank you. Take x, which is 2019, divide by 19. Now, is that right? Divide by 19? 2019 divided by 19. That's weird. Okay. Don't whip out your calculators. Okay. How many times does 19 go into 2019 evenly? 100. Somebody check me. 106? 106 times 19 is that, right? I think. I'm just scratching stuff out here. You'll have to check me. That's the quotient. We don't care about that. We care about the remainder. So if 19 goes into 2019 106 times evenly, 106 times 19 is 2014. What's the remainder? And that's what I really care about, A. What would be the remainder? Shout it out if you're wrong. I will not yell and scream. 5. How'd you get 5? Yeah, that's right. 2019 minus 2014. That's 5. A. Cool. All right. We're going to do another one in just a second. Questions? While I tell the joke, think about questions that you might have. Okay? All right. So we've been talking about Easter, and if you've had Religion 100, 110, or you are a Christian, you know that it is the most important holy day that there is. Jesus' victory over sin, death, and the devil. Well, this is something Dr. Pavla does not tell you in Religion 100. Have you heard about the rematch between Jesus and Satan? You have not. So early in the 21st century, Satan came up, knocked on the door of heaven. Michael the archangel, now remember, angels look like Chuck Norris. Michael the archangel answered the door and said, "What do you want here?" He says, "I demand a rematch. I got ripped off the first time." Michael rolled his eyes and said, "Okay, but I tell you what, since it's the 21st century, I think what we're going to do, we're going to have a little programming contest between you and Jesus. You up to it, devil?" "Sure." So on the appointed day, the archangel Michael leads both Jesus and Satan into a room. There are 2 tables, and on one is a PC, on the other is a Mac. I guess you'll just have to figure out who went to which machine. And they each sit down, and Michael says, "Okay, here's the rules. I'm going to explain an idea for this software application. After I explain the idea, you each have 60 minutes using the hardware in front of you to implement the software. At the end of the 60 minutes, I'm going to interact with the app, see which one's better, and that person be declared the winner. Fair?" Fair. So Michael explains the problem. Both Jesus and Satan think about it, and then Michael says, "Go." They both start typing furiously on their computer systems. 59 minutes, 15 seconds into the programming contest, the power goes off just for a split second. Do you know what happens if the power goes off on a desktop machine? Do you know what happens to all your stuff you've been working on? It's gone. It's gone. Satan says, "What the happened? What's going on?" Well, he moans and groans for 45 seconds, and Michael looks at his Rolex and says, "Okay, time's up. Satan, do you have anything?" He says, "You know I don't have anything. The power went off. I lost everything." Michael turns to Jesus and says, "Jesus, do you have something?" Jesus says, "Yes." Michael sits down, works with it. Of course it's perfect. Satan asks Michael, "How did he do that?" Michael says, "Well, I thought everybody knew. Jesus saves." By the way, if you're working on a desktop system, it's a good idea to save your work every so often. Is that okay? All right, good. All right. Questions on Easter in general, what's happening here, the algorithm? Okay, let's look at another algorithm. This is called greatest common divisor, or GCD. You've likely all seen this before in a math class somewhere. This algorithm was developed by an old dead Greek guy. He did it before he died, Euclid, about 2,300 years ago. The greatest common divisor algorithm is a way to determine what's the largest number that evenly divides two other values. Here's the algorithm. Now, the algorithm is shorter than the Easter algorithm, right? Kind of cheating. I mean, I got 3A, 3B. I should change this. There's 4 steps and a couple intermediate steps. Shorter than Easter, to be sure. But it's more complex for several reasons. So just because it's shorter doesn't mean it's easier to understand or to create. Why is it more complex? First of all, this algorithm employs something called repetition. I bet you can figure out what that means. Certain things are going to be repeated. For example, see this here? Repeat at step 2. Go back, do that again. Maybe several times. Repetition. The second thing that makes this more complex is a concept in computer science we call selection. Selecting is choosing. For example, you're not going to do both 3A and 3B. You will choose or select one or the other. If the remainder is not 0, if the remainder is 0. You don't do both of these, you'll select one or the other. And the next thing that makes it a little more complex than Easter is, in addition to arithmetic operations, this is going to use logical operations, comparisons. For example, if the remainder is not 0, that's a comparison. 0? Yes, no. Is the remainder 0? That's a comparison. So let's step through this algorithm, and then I'm going to ask you to step through it. Just make sure we all can do it and see if you have any questions. So, for example, maybe we want to find the greatest common divisor of 30 and 18. Now, you can do that in your head. You can look at those, say, yes, 2 will evenly divide it. It's not the biggest one, right? 3 will, it's not the biggest. All right, let's just follow through the algorithm just to see how it works. Step 1, if it helps, maybe I'll. By the way, if you want to write this down, make a big box, because what I'm going to do is I'm just going to X out things here rather than trying to erase them. So here's my 2 initial variables, larger and smaller. The algorithm says take the bigger number, put it in the variable called larger. Take the smaller value, put it in the variable called smaller. That's step 1. Easy. Bless you. Step 2, divide. Ooh, again, this is integer modulo division. Don't whip out the calculator. Quotient remainder. Okay? So 30 divided by 18. 18 goes into 30 just one time evenly, right? 2 18s is 36. So just one. That's a quotient. The algorithm says ignore that. And then, what is the remainder? Well, 30 minus 18, since 18 just went in there one time, is 12. Remainder 12, I'll remember that. Now for step 3, I got to select. I got to ask a question and answer the question. It's phrased a little funny, isn't it? I mean, it's not how we'd usually. Is this not 0? Yes, this is not 0. So then I do those sub-steps under 3a. If the remainder 12 is not 0, then sub-step 1. We're going to talk about this. This arrow means to assign. I'll write it down in a minute. A-S-S-I-G-N. What this is saying is take the current contents of the variable smaller and put it into larger. Well, what happens to larger? The answer is it used to be 30. We're going to cross that out, and instead it will have a new value. Larger now becomes 18. This is called assignment in computer science. Assign. Think of it as replace. I'm going to replace what was in larger with the value of smaller. That's the first step under 3a. The second step under 3a is to now, so that's the first step. The second step is now to assign remainder to smaller. Remainder used to have, smaller used to have 18. I'm now going to cross that off, and it will have 12. Cool. And now repeat at step 2. You're saying, well, I already did step 2. How's it going to be different? Answer, different values. The first time at step 2, we were dividing 30 by 18. Now we're going to divide 18 by 12. Well, again, 12 goes into 18 only one time. We'll ignore that. But it has a remainder of 6. 18 minus 12 is 6. So now, remainder used to have 12, but now I'm going to replace that, assign a 6 to it. Keep. Cool. Now, step 3a again. Is this not 0? Sounds funny. Yes, not 0. What do I do? First subset again. I'm going to replace what's currently in smaller, 12, put that into larger. So the 18 goes away. Larger becomes 12. Take remainder, assign it into smaller. Smaller used to have 12. Now smaller is going to be 6, the current value of remainder. And then repeat again. Whew. Is this ever going to end? Yeah, right now. Step 2 says take larger, divide by, larger is 12, smaller is 6. 6 goes into 12 2 times evenly, right? 6 times 2 is 12. So the remainder now is 0. 0. So I put 0 into the remainder variable. And now in step 3, I'm going to make a choice. Is it not 0 or is it 0? Well, guess what? It is 0. That's step 3b. If the remainder is 0, true, then the greatest common divisor, fourth variable, is smaller, 6. Is that true? Is the greatest common divisor of 30 and 18 6? Yes. 6 will evenly divide 30. 6 will evenly divide 18. But no number larger than that will evenly divide both of them. Here it is. Cool, huh? Yeah. Would you like to try? Good. I'm going to ask you to do this. I'm not going to ask you to turn in your notes, but you really want to do this. You want to write it down and follow it because I'm going to ask you to do this on the homework assignment. So if something's fuzzy right now, let's clear it up. I'll put the algorithm back on in a minute, but this is what I want you to do. Oh, and I want you to tell me how many times step 2 is done. So keep track of that too. All right. So, sorry, I know you can't do this, but I'm just going to erase the contents of my variable boxes here. I want you to find the greatest common divisor of 35, which is larger, and 14, which is smaller. I know you can just look at it and do it in your head, but follow the algorithm. So Would you follow through the steps there? And I'm also going to ask you how many times the division is, step 2, instruction 2 is performed. Are you ready? Go, just write it all down. Even if you didn't get all the way through it, let's take a look. What is the answer, by the way? To here. 35 and 14, greatest common divisor is? I'm going to guess 7. Let's take a look. Okay. Oh, yes. How many times is instruction 2, that division, performed? That is done 2 times. Does that seem tricky to you? Sometimes people don't count the first time. 1 here. Okay, large and small. So what happens? 35 divided by 14. How many times does 14 go into 35 evenly? 2 times. 14 times 2 is 28. 35 minus 28, that's 7. Remainder is 7, right? It's not 0. So now I reassign things. Used to be that, used to be that. I go back to step 2, divide 14 by 7. 7 goes into 14 2 times evenly, remainder of 0. Go to 3b, GCD, 7. Cool. So step 2 is done twice. GCD is smaller, 7. What do you think? Okay? All right. 2 times. I made your favorite Euclid, pi. Yeah, Euclid also had something to do with the idea of pi. Okay, sorry, a little math humor. Folks, online at Blackboard, you will find assignment number 2. Sorry, I know there's some overlap. You haven't completed 1 yet. Typically, there won't be overlap. Homework assignment 2 is going to ask you to do, 2 things. Number 1, follow the Easter algorithm. And I want you to determine it for this year. This is 2019. I'm only going to ask you to write down the full thing on 2 steps. I think it's steps 6 and 8. But you can't short circuit it. You can't say, oh, I'll start at step 6, because step 6 requires step 5, and 5 requires 4. So you might as well do the whole thing. But I want to see your results for step 6 and step 8. And then also I'm going to ask you to go through GCD for 2 other values. I forget what they are. See it at Blackboard. and then answer some questions regarding that. Assignment 2 is due 1 week from today, whatever that might be. I don't know, today the 6th? Okay, I don't know either. So 1 week from today, Blackboard will tell you. You will upload, create a data file, use WordPad or a word processor, upload that, and you'll be set. Cool. I'll talk more about assignment 2 next time, so if you look at it before next time and got questions, ask them then. That'll be helpful. So let's review the grand ideas of computer science. These are the 3 that we're focusing on in Unit 1 right now in CSC 150. Algorithms, abstraction, automation. You should know both the definition and applying in context. For example, last time, algorithms, instructions for solving a problem. What's it mean in the context of geoclock? Well, these are the instructions for determining where the light is shining on planet Earth, given the current date and time. Or you can think about face recognition or anything else. In the second unit of this class, we're going to investigate 3 additional grand ideas. Information. By the way, we've talked about that already. We gave a pretty straightforward definition as useful process data. We'll expand that. Interface. We've all worked with a user interface. And then intelligence, which we've already talked about a little bit, one of those attributes or characteristics of human beings resulting from the image of God, human intelligence. Nice. So we won't forget about the first 3, but when we get to Unit 2, we'll sort of focus on those 3. And then in Unit 3, we'll focus on 3 additional grand ideas. Cognition. Abstractly, it means to understand. Cognition means understanding. Complexity. Probably sort of know what that means. It's bigger than what you think. And then finally, creation. And yeah, you know what creation is, bringing something new into existence. So there are the 9 grand ideas of computer science. In this unit, we're focusing on the first 3, and we'll bring them in little triads as we move along. Not necessarily anything special about the order. It could be, as most people believe, that algorithms are the most important idea, so I just start there. These others are not less important. They're really important too. Okay. Yeah, we will continue to talk about those not just next time, but also in the future. Cool. All right. So don't forget, next time, homework assignment 1 is due. I want hard copy, please. Please word process something. Don't write something up longhand the last second. Word process this. If you have a physical ad, staple it to it, print out the first page of your online thing, or you don't want to do any of that, put the URL, the link on there so I can review it too. Remember, you're looking for not a mobile device. Don't do a phone, don't do a tablet. Do a laptop, a desktop, etc. Needs to be recent. Please don't find an ad on Craigslist for a Dell 1200 with something a little bit recent so we can do some stuff. And then if you look online at Blackboard about about assignment 2, because we'll talk about it a little more next time. You got questions, bring them up. We're done. Have a nice day. Have a happy Thursday. See you on Friday.